In this video, we're going to be learning how we can calculate distances on a number line. The shortest distance between any two places is in a straight line. Between any two numbers, any 2 points, anything is in a straight line. Today, we're going to learn how to calculate straight line distances between any 2 points. Remember that distance can only be positive. You can't drive negative miles in your car. You can't run negative miles, all right? The distance is always positive. In our example, number one, we're going to plot the numbers -3 and 2 on our number lines. So here's where -3 is, 3 units to the left of 0. And here's where 2 is, 2 units to the right of 0. I want to be able to calculate this distance from -3 up to +2. All right. So in part A, it says evaluate each of the following. -3 minus 2. Well, remember that -3 minus 2 is the same as -3 plus -2, which would give us an answer of -5. And 2 minus -3 is the same as 2 plus 3, which is +5. All right, so in each of these examples, I used the values of the numbers that I plotted and I subtracted them. -3 minus 2, 2 minus -3. And notice that I don't get the same answer because subtraction isn't a commutative operation, but I do get two answers that are opposites from each other. Now, what is the distance between each of these 2 points on our number line? Well, if we start at -3 and count up to 2, 1, 2, 3, 4, 5 units away, those 2 points are located. Okay, so the distance between those 2 points is 5 units. All right, now in each example that I did with the subtraction up above, all right, well, I got -5 here and I got +5 here, and the distance is 5 units. How can we ensure that subtraction will give us the distance no matter what order we perform the section in? Okay, well, this subtraction problem right here did give us the distance of 5 units, but this subtraction here did not give me a distance because distance can't be negative. I never want distance to be negative, so to ensure that I get a positive answer when I do the subtraction, all right, I can use absolute value, because absolute value measures a number's distance from 0, and again, distance can only be positive. If I use absolute value with my subtraction, I'm always going to get a positive answer. All right, if I took the first subtraction, -3 minus 2, and put it in absolute value bars, well, again, absolute value bars are very similar to parentheses. If you have an operation inside, you have to do that first. Okay, so I'm really asking for the absolute of -3 minus 2, which is -5, and the absolute value of -5 is 5. So that will allow me to get a positive distance, even though when I first did the subtraction, my answer was negative. Okay, now my second problem was 2 minus -3, 2 minus -3. And again, if I put that in absolute value bars, that's going to be the absolute value of +5, which again is equal to 5. Okay, so if you use absolute value bars, you can do the subtraction in any order for your 2 points here. You're still going to get the same answer to represent the distance. And so that's the big takeaway here today. In order to find the distance between any 2 points, we're going to do a subtraction problem, but we're going to put it in absolute value bars to make sure that our answer is positive. So again, our key idea for our video, in order to calculate distance on a number line, I'm going to do a subtraction problem. But again, to make sure that my answer is positive, I'm going to put my subtraction in absolute value, all right? If P and Q are two rational numbers on the number line, then the distance between P and Q can be found by calculating either the absolute value of P minus Q or the absolute value of Q minus P. The order that you do the subtraction isn't going to matter as long as you put the subtraction in absolute value bars. You will get the same distance. All right, so in our next example, plot the numbers -6 and -10 on the number line below. All right, here's -6, 6 units to the left of 0, and -10 is 10 units to the left of 0. This is the distance that I want to calculate. All right. Calculate the distance between these 2 points two different ways, and then we can verify our answer with our number line. So Again, I can find the distance between the 2 points by subtracting them and putting the subtraction in absolute value bars, and I can set the subtraction problem up 2 different ways. All right, so if I want to start at -10, I'm going to subtract off the other value, which is -6. But to make sure that this answer becomes a positive number for my distance, I'm going to put it in absolute value bars. Okay, so this is one way that we can set up the problem. All right, now I'm going to have to do what's in the, not in the parentheses, but in the absolute value bars first. All right, how much is -10 minus -6? All right, well, remember, -10 minus -6 is the same as -10 plus 6. All right, and -10 plus 6 is -4. And here is why I need the absolute value bars, because distance can't be a negative number. But now if I take the absolute value of -4, I'm going to get an answer of 4 units. All right, these two numbers are 4 units apart. 1, 2, 3, 4 units apart. Okay, but that's just one way we could have set up the problem. All right, 2 different ways. Well, I could have reversed the order. I could have started at -6 and then subtracted off the other number, which again was -10. And again, I want this answer to be positive, so I'm going to put the subtraction in absolute value bars. Now let's do the subtraction inside of the absolute value first. 6 minus -10, well, that's the same as -6 plus 10, which is equal to +4. And the absolute value of 4, again, is 4 units. Okay, so again, the subtraction, the order that you set it up doesn't matter. As long as you do the subtraction in absolute value bars, you will end up with the same distance between the two numbers. Let's do some more practice calculating distance on a number line, but you'll notice here I don't actually have a number line for these examples. So what we're going to do, again, to find the distance between the two values, we're going to subtract. We're going to do the subtraction inside of absolute value to make sure that our answer comes out to be a positive number. All right, so for each of these, we're going to set up the problem using subtraction in absolute value. I'm going to set it up both ways just to show you how you could set it up either way, but you only have to do one way on your paper, okay? So if I wanted to find the absolute value of the distance between -4 and +5, I'm going to subtract the numbers, and I can subtract it in any order. So I can do -4 minus 5, and to make sure the answer is positive, I would put it in absolute value bars. Or I could do 5 minus -4, and again, put it in absolute value bars in order to get a positive distance. Okay, so for -4 minus 5, all right, well, this is the same as the absolute value of -9, because -4 minus 5 is the same as -4 plus -5. That means that the absolute value of -9 equals 9 units. So on a number line, -4 and 5 would be 9 units apart. All right, similarly, 5 minus -4, that's the same as the absolute value of 9, because 5 minus -4 is the same as 5 plus 4. And again, the absolute value of 9 is 9 units. All right, so -4 and 5 are 9 units from each other on the number line. Letter B, how far apart are -5 and 27 hundredths and -3 and 91 hundredths? Well, again, no number line here, but we can set the problem up by doing subtraction in absolute value. Okay, so I could do -5 and 27 hundredths minus -3 and 91 hundredths in absolute value. Or I could do -3 and 91 hundredths minus -5 and 27 hundredths, again, in absolute value. These will both give me the same answer because of the absolute value. You can calculate how much this is going to be. -5 and 27 hundredths minus -3 and 91 hundredths. Well, that's the same as -5 and 27 hundredths plus 3 and 91 hundredths. Okay, so when I do -5 and 27 hundredths plus 3 and 91 hundredths, I get -1 and 36 hundredths. But it's still in absolute value bars. So now when I go ahead and figure out the absolute value, I'm going to get 1 and 36 hundredths units as the distance between those two numbers. Okay, similarly down here, -3 and 91 hundredths minus -5 and 27 hundredths. Well, that's the same as -3 and 91 hundredths plus +5 and 27 hundredths. So when I do that problem in absolute value, I'm going to have 1 and 36 hundredths. And then the absolute value of 1 and 36 hundredths is just 1 and 36 hundredths units. Letter C, what's the distance between -3 halves and 13 sixths? Well, again, we can set this problem up two different ways using our subtraction and absolute value. Okay, so let's do -3 halves minus 13 sixths to start in absolute value bars. Okay, well, one thing I notice here is that these numbers don't have the same denominator, so I'm going to have to get a common denominator. Halves and sixths, I like sixths, so I'm going to change -3 halves into, well, 3 times 2 is 6, so 3 times 3 is 9, so that's going to be -9 halves minus 13, or excuse me, -9 sixths, I should say, excuse me, -9 sixths minus 13 sixths. All right, and now when I do the subtraction, -9 sixths minus 13 sixths is the same as -9 sixths plus -13 sixths. So that's going to give me the absolute value of -22 sixths. And then if I do the absolute value of -22 sixths, I get 22 sixths, which I can then simplify down to 11 thirds. And then that is equivalent to 3 and 2/3 units. Okay, so these two fractions on the number line, they're 3 and 2/3 units away from each other. I could have set it up the other way, 13 sixths minus -3 halves, again in absolute value bars. Get those common denominators, I can keep 13 sixths, all right? But again, -3 halves is the same as -9 sixths, which I am subtracting there. And now when I do the subtraction, subtracting -9 sixths is the same as adding +9 sixths. So 13 sixths minus -9 sixths is +22 sixths. And again, when you do the absolute value, you again get 22 sixths, which then, again, you can simplify to 11 thirds or 3 and 2/3 units apart on the number line. Let's try a couple of distance word problems. All right. In example number 4, find the change in temperature if the temperature rises from -18 degrees to 15 degrees Fahrenheit. All right. So I'm looking for the distance between these two temperatures on a thermometer. So again, if I want to find the distance between any 2 points, any 2 numbers, I'm going to subtract the numbers and I'm going to put that subtraction in absolute value to make sure that my distance is positive. So I can start at -18 degrees and subtract 15 degrees. And if I do that problem in absolute value, I should get the distance between the 2 temperatures on a thermometer. All right, well, this is going to be the absolute value of how much? Well, -18 minus 15 is the same as -18 plus -15. And so if I figure that out, well, -18 plus -15, that's -33. And the absolute value of -33 is 33. All right. Or I could have started at 15 and subtracted the temperature -18 degrees. And that subtraction in absolute value will again get me the same distance. All right. Well, 15 minus -18 is the same as 15 plus 18. And 15 plus 18 is 33. And the absolute value of 33 is 33. Okay, so the temperature, we can say, the temperature changed by 33 degrees. All right, those two temperatures on a thermometer are 33 degrees apart from each other. In example number 5, Benny and Jeremy are running a race. Since Jeremy is faster, he will start 15 feet before the starting line, and Benny will start 13 feet after the starting line. All right, if 0 represents the starting line, calculate the distance between their starting points. All right, so we can imagine a number line here. All right, and there's 0. Now, it says that Jeremy's faster, so he's going to start 15 feet before the starting line, which is 0. 15 feet before the starting line is here at -15. Okay, so that's where Jeremy is beginning. I can put a J there for Jeremy. Benny is 13 feet after the starting line. So 13 feet after the starting line is going to be here at positive 13, and that's where Benny is starting. So how far apart is this distance between their starting points? Well, again, we can do a subtraction. We can take Jeremy's starting point, negative 15, and subtract off Benny's, and make sure that we do that in absolute value. All right. So that's going to be the absolute value of, well, negative 15 minus 13 is the same as negative 15 plus negative 13, which equals negative 28. And then the absolute value of negative 28 is 28. All right, so I could have started with Benny's starting position of 13 and subtracted off Jeremy's at negative 15. And again, that subtraction in absolute value will give me the same distance. This is going to be the absolute value of, well, 13 minus negative 15 is 13 plus 15, which is 28. And the absolute value of 28 is 28. Okay, so Benny and Jeremy are starting 28 feet apart from each other. All right, Benny and Jeremy are starting 28 feet apart from each other. Letter B, if Jeremy runs 4 feet per second faster than Benny, how long will it take for Jeremy to catch up to Benny? Well, we know that they're starting 28 feet apart. All right, and if Jeremy goes 4 feet per second faster than Benny, all we need to do is take that distance of 28 feet and divide it by the 4 feet per second, and that will tell us how long it's going to take Jeremy to catch up. 28 divided by 4 is 7, so we can say it will take Jeremy 7 seconds to catch up with Benny. All right, and that's all there is to it. So again, if you want to find the distance between any 2 points on a number line, you're going to set up a subtraction problem in absolute value bars in order to find that distance, because again, we need our distance to be positive, which is why we need the absolute value bars. The order of the subtraction doesn't matter because we will be taking the absolute value.